Alright, 3.4 equations of lines. Students will be able to find equations of lines given the slope and points on the line. A couple things we need to know real quick. A few different forms that you need to be aware of. You got the standard form, ax plus by equals c. In this form there should be no fractions. A should be positive. And if you wanted to find the slope real quick, you just take a divided by b, slap a negative in front. And that's all there is to it. Then there's the slope-intercept form, which most of you guys are familiar with, y equals mx plus b, where m is your slope and b is your y-intercept. And this one is probably one you haven't seen before, but it is a good one. Y minus y1 equals m times x minus x1. Okay. So let's take a look at this. It says convert the following equation from standard form to slope-intercept form and then graph. So we want to convert it to slope-intercept form. That means that we want the y all by itself. So really we're just going to solve this equation for y. So first things first, subtract the 4x, and you have negative 2y equals negative 4x plus 9. Now we're going to just divide everything by negative 2, and we get y equals 2x minus 4.5. Alright, now it's in slope-intercept form, and now they want us to graph it. We start with my y-intercept, which is negative 4.5. Go to that point, go down 4.5 right there. Let's do it in blue so it's a little bit easier to see. And it says my slope is 2. Right, because there's a 2 right in front of the x, so that means that I'm going to go up 2 over 1. So up 2 over 1, up 2 over 1, and just connect all those dots. And there's my graph. Simple as that. Alright, this one's in point-slope form, and you're trying to get to slope-intercept form. Again, all you're trying to do is get the y by itself. I'm going to let you guys go ahead and try that and graph it, and I'll put the answer up in just a second, so you may want to pause the video now. Okay, so let's zoom in on this problem. First thing I did is I distributed the negative 3, so I got negative 3x plus 6, and I subtracted 5 from both sides, and I got negative 3x plus 1. 6 plus 5 is 1. When it comes to graphing that means I'm going to go to positive 1 on my y-axis right there. I'm going to go down 3 over 1, down 3 over 1, and connect the dots. All there is to it. Alright, let's go to the next page. Alright, now it says find the line given 2 points. So, negative 1, 6, and 3, 2. The first thing we have to do whenever they give us 2 points is find the slope. And you may remember from the last lesson that the slope formula is y2 minus y1 over x2 minus x1. And we could kind of label these x1, y1, x2, y2. And let's just go for it. We got 2 minus 6 over 3 minus negative 1. 2 minus 6 is negative 4. 3 minus a negative 1 turns into a positive. So it turns into a positive 4. Negative 4 divided by 4 is just negative 1. So there's my slope. And look at this. I have some points and I have a slope. Well, if we go back to the last page, we'll see that there's a beautiful formula for that. It's called point-slope form, and now we get to see how to use it. Plug in, I got a y minus my y1. In this situation, I could use either set of points, it doesn't matter, but I'm going to use the x1 and the y1 that we have. So y minus y1 is 6 equals, my slope is negative 1, x minus my x1 is also negative 1, so it turns into a positive because it's a negative and a negative. And that's it. I'm done. Now there's another way you can do this using a different form, so I'm going to show you that way off to the side just so you're aware. But I wouldn't recommend it. Just let me say that. I think this is an easier way to do it. But if you want, there's another way. Y equals mx plus b. Right? We know that form. Maybe you're more familiar with that one. Well, what we're gonna do is use the same points, and I'm going to temporarily plug them in for my y and my x. So, instead of y, I'm going to put a 6. Instead of an m, I'm going to put -1 because that's my slope. Instead of an x, I'm going to temporarily put my x value, which was also -1, and then plus b. So we get 6 equals -1 times -1 is 1, plus b, subtract 1, b equals 5. And so then I could write my equation as y equals -1, x plus 5 for my b. So these two equations are really the same. In fact, if you were to take this equation and distribute the -1 and add 6 to both sides, you'd get the same thing. So either one of those are fine, but you're going to find that this one is going to be a lot simpler when you're just trying to get an equation, because notice it doesn't tell me what form it needs, it just says find the equation. Well, this is an equation. So go ahead and do practice number 4, and I'll put a few different answers that could be possible up there. Remember that you could have used these points too, and you would have gotten a fine equation as well. And let me say this: these points C and D are the same, so you don't want to do those. You're going to get. So I would try 1 and -2 instead. Go ahead and try those ones. And I'll put the answers up in just a second, so I'd pause the video now. Okay, here's your 3 answers that you should have got if you used this point. Well, first of all, you should have got a slope of -4, so that's the first stuff. And then if you use this point, this was your point-slope equation. If you use 1, -2, this is your point-slope equation. And if you didn't use either of those and you use slope-intercept form, then that should be your equation, and you should have gotten a 2 for B when you solved. Okay, let's talk about a couple more here. This one says, write an equation in slope-intercept form for a line containing the point 2, 0 that is perpendicular to the line y equals -x plus 5. So it's perpendicular to this line. Why are they telling me anything about this line? Well, that word perpendicular and this word parallel in the next problem should be a flag that they want you to figure out what the slope is. So the slope here is -1. But it's perpendicular. So what is the perpendicular slope to -1? Well, remember, if I have a slope of, let's say, -a over b, that means the perpendicular slope is going to be b over a, and you either take away the negative or you add a negative, and here we're going to take it away. So in this situation, here I have -1. Well, that's the same thing as -1 over 1. So when I flip it, I'm going to have 1 over 1, and I took away the negative. So my perpendicular slope is just 1. Okay. Now if this was -1/2, then my slope would be 2, because 1 over 2, flip it, I'd get a 2, take away the negative. So my slope that I'm going to use is 1, and I have a point, 2, 0. So let's plug it in. Y minus my y1 is 0 equals a slope of 1 times x minus 2. Y minus 0 is just y. Distribute the 1 and you just get x minus 2. There it is in slope-intercept form. Alright, I want you guys to try the next one on your own. A little bit trickier, but not too bad. A couple things I'm going to say though. This time they're telling you it's parallel. Well, why do you think they're telling you parallel? That's because they want you to look at the slope. The slope here is -2. So then what is the parallel slope? Well, parallel slopes are the same. So this one is -2 as well. That's the slope you're going to use, -2. Do the same thing, use point-slope form, plug in your point, plug in your slope, and then convert it to slope-intercept form. I'll put the answer up in just a second, so you may want to pause the video now. Alright, when you plug it in, you get y plus 2 equals -2x minus 3. Distribute the negative. Subtract 2 from both sides, and you get y equals -2x plus 4. Alright. The last thing I just said in the summary is describe what is the minimum information needed to write the equation to a line. See you guys in the next video.